Okay, so we're going to cover a really popular topic. This is going to be glycolysis. So essentially, as an overview, glycolysis is the degradation of glucose, the breakdown of glucose, and therefore this is a catabolic reaction. Now, if you don't know a catabolic reaction, the opposite of an anabolic reaction is where we break something down to form energy, to produce energy. That is a catabolic reaction, and it's composed of 10 reactions, 3 of which are irreversible, and a net of 2 ATP is produced, and we'll see this at the end in our breakdown where we have the overall balance of the glycolysis. So we have 2 main phases. We have the preparatory phase, and we have the payoff phase. So phase 1 and 2. Phase 1 is composed of reactions 1 to 5, and payoff phase is 6 to 10. And of course, it's important to remember it's located in the cytoplasm. Okay, so moving on to phase 1, the first reaction is going to be the glucose being converted into glucose 6-phosphate. Now, this is going to be catalyzed by an important enzyme you need to remember. This is called hexokinase, and this, of course, is a phosphorylation reaction. Remember, kinase is for phosphorylation, the addition of a phosphate group, and the addition of a phosphate group is going to require an ATP to be used and consumed. So subtract 1 ATP. Then we're going to convert glucose 6-phosphate into fructose 6-phosphate. And this is a reversible reaction. And this is simply just some isomerization. We're just changing the glucose to the fructose. Still the same chemical formula. Okay, so then fructose 6-phosphate is going to be converted into fructose 1,6-bisphosphate. This is an irreversible reaction, and again is also phosphorylation. So this is going to be using the enzyme phosphofructokinase 1, another kinase enzyme. And again, because it's phosphorylation, we're going to use an ATP. Now onto the next reaction. This is a reversible reaction. From fructose 1,6-bisphosphate, we're going to split it into 2 similar molecules. These are going to be triose phosphates, one being glyceraldehyde 3-phosphate. This is one of the triose phosphates. And we're going to have another molecule produced, which is going to be dihydroxyacetone phosphate. So these are the 2 triose phosphates. They're not identical. The similar ones produced from this fructose 1,6-bisphosphate. And then, of course, another reversible reaction converts them into 2 identical triose phosphates. So if we move on now to the phase 2, the payoff phase, this is where we get our ATP, what we've been looking for. So we have glyceraldehyde 3-phosphate. If you remember, this is one of the triose phosphates from before. And remember, for each of these, we have 2 lots of them because we made 2 triose phosphates. So this is a reversible reaction, converting it to 1,3-bisphosphoglycerate. And this is actually going to give out NADH and a proton. And of course, 2 of these because we have 2 of the glyceraldehyde 3-phosphates. And again, this is oxidation and phosphorylation. Then we'll convert 1,3-bisphosphoglycerate into 3-phosphoglycerate. So if you look, we have basically dephosphorylated. We've taken one of the phosphate groups out. And you can see that how we've changed from 1,3 bi to just 3. So instead of 2, we have just 1 now. It's a 3rd carbon. And this gives us 2 ATP, removing a phosphate group. Then another reaction converts to 2-phosphoglycerate. And this simply just moves the position of the phosphate group. It's a very simple reaction. Then we convert it to phosphoenol pyruvate, and this is a dehydration reaction, giving out water. Dehydration always gives out water. And again, 2 of everything, so we have 2 waters. And finally, we're going to convert the phosphoenol pyruvate into 2 lots of pyruvate. And this is going to be using the pyruvate kinase enzyme, another dephosphorylation, giving out another 2 ATP. And remember, all those reactions were 2 lots of everything. So if we look at the balance here to finish up, we can say the preparatory phase is a negative 2 ATP. So we actually used 1 ATP for each phosphorylation reaction we had. We had 2 reactions of phosphorylation. And the payoff phase, we gained 4 ATP, 2 NADH, and 2 pyruvate. So the overall balance is positive 2 ATP. and hopefully that will make sense.